All right, so today we're actually going to do part of section 11.4, which is talking about summation techniques mostly. There's actually 4 meaty topics in section 11.4, and we're only going to do one of them this week. It's basically what's going to take us through the next 4 weeks is this one section. So we're going to talk about summation techniques, and specifically today, what do you do when the formula for a sub n is a polynomial? So it's not arithmetic, it's not geometric. Could be quadratic, could be cubic, could be quartic, quintic. Oh, so what do you do? And it's actually not that bad. It can get a little tedious, but it's really not that bad. So this is going to require that you have some formulas memorized. I say memorized. No, you don't have to have them memorized for this because everything's going to be open notes. But really, in general, it's a good idea to have these things kind of handy, to whip out. So I would encourage you guys to memorize them. You're definitely going to use them next year in calculus. And then I imagine you'll see them in trig pre-calc if you're going to take that. I'm not sure. But you'll see them in calculus. We actually use these to talk about something called integration. Anyway, what are the formulas? So these are the formulas right here. And so let's just talk about them real quick so we can get our brain around what's going on. One of them is the summation of I, which is just the natural numbers. So it says, notice by the way, all of these I goes from 1 to n. It's very important that you have to be starting at 1. If your lower limit is not 1, these formulas, you would have to adjust for it. So anyway, I starts at 1, so you plug in a 1 for I, and it's 1. Then you go to 2, I equals 2, and you plug in I equals 2, and you just get 2. When I equals 3, I equals 3. Like, it's really easy. So anyway, you just add them all up until you get to the last term, which is going to be stopping at n. So you plug in an n for I, and there's your last term. So it's just a summation of the numbers 1, 2, 3, 4, all the way up until n, and it turns out that wherever you stop, that value for n, this is the formula that you can use to add up all those numbers. And then we have the summation of I squared, which is now we're just squaring each term. But if you add up all these numbers, this is the formula. And then I cubed, those numbers, that's the formula. These are the 3 that you should have memorized. And for tonight's homework, these are the only 3 that you have to know. If you're curious, I mean, I'm sure on the internet there's like tables that go all the way up. There's actually ways to derive the formulas going up even more than I cubed. But there's a couple more formulas in case you're curious. More formulas on page 836 in your textbook. They have the summation of I to the 4th and I to the 5th. And honestly, I don't have those memorized. But these I do. So we have these. Now there's one more formula that you should know, and this is an easy one to have memorized, but it's a little weird the first time you see it. So it's the summation as I goes from 1 to n, so starts off the same, except our argument is just a constant. I'm going to put c for a constant. So wait, what? What is that? Well, you actually have all the knowledge you need to be able to figure that one out. So if you want to pause the video and think about it, that would be great. I encourage you to do that. And we're going to talk about it in a moment. So hopefully you paused the video, but let's talk about what this is. So if you were working this out and you got n times c, then you would be correct. So let's talk about where that comes from. Remember, it says I goes from 1 to n. So you're going to let I equal 1. And even though there's no I in the argument, you still have to think, okay, if I equals 1, what's the value of c? It's just c. And then when I equals 2, what's the value of c? Well, it's still c. And if I equals 3, what's the value of c? Still c. And if I equals 4, what's the value of c? It's still c. And if you kept this up all the way until the end, when I is n, what's the value of c? It's still c. But the key is, because we started when I was 1 and went all the way to n, we wrote c n times. So when you're adding c n times, that's the same thing as n times c. And so nc. And so we're going to use all of these formulas for our homework. And we're going to do them in the examples. Okay, so like I said, there's going to be 3 examples, and then we'll be done for today. So the first example, example 1. Let's say that you are given a sub n is equal to n squared plus n plus 1, and we need to find a formula for the nth partial sum, s sub n. So how would that work? Well, it's actually not that bad if we think about it. So we know the nth term. What does it mean to be a sum? Well, remember that we can just write it as a sigma notation really easily. So this means that s sub n is the summation as I goes from 1 to n of I squared plus I plus 1. Your formula for a sub n just becomes the argument for your summation. Now let's talk about a few things specifically. Here. First of all, why did I change from n to I? Well, we're talking about the nth partial sum. So we're talking about adding up the first n terms. That means we're going to stop plugging in when we get to n. We're going to plug in 1, then we're going to plug in 2, then we're going to plug in 3. We don't know where to stop. The only thing we know is we're stopping at whatever the nth term is. So I have to use n as my upper limit, which means I have to use a different variable here. I can use any variable I want. I just chose I, but the only thing is you can't use n. So I just use that. Now the other thing is, why can I do this? Why can I just put this formula as my argument? Well, if you think about it, it's actually pretty simple. So let's take a look at this first. A sub n equals n squared plus n plus 1. That means the first term is 1 squared plus 1 plus 1, which is just 3. And the second term is 2 squared plus 2 plus 1, which is 4 plus 2, which is 6. That's going to be 7. And the third term is 3 squared plus 3 plus 1, which is 9 plus 3, which is 12. Hopefully I'm doing my arithmetic correctly. But you see I'm getting the first and the second and the third term. And I would just keep doing this. I would let n equal 4 and plug it in and so on. But then the summation as I goes from 1 to 3, let's just say I stopped at 3. Of this guy right here, which is the same exact one I have here, I'm going to let I equal 1. 1 squared plus 1 plus 1 is 3. Then I let I equal 2, and I'm going to work out 2 squared plus 2 plus 1, which is 7. And then I'm going to end at 3, which is 3 squared plus 3 plus 1, which is 13. So you can see I'm just getting the actual terms. That's the first term, that's the second term, that's the third term of the sequence, but now I'm adding them up. So the argument for your summation is just going to be your formula for a sub n. So it's kind of nice. I gave it to you, so I basically gave you that. So we have this part. All right, that's just kind of a little extra though. Normally we don't have to show all this work. That was just to explain this first example. So I'm just going to kind of put it off to a cloud, leave it there. Let's look at how we actually do this. So what you're going to want to do with this guy right here is you're going to break it up. We can see something that kind of resembles these. We have an I squared in there, we have an I, we have a constant, but these are separate summation formulas. What do we do when they're all combined? Whoops. What do we do when they're all combined into one summation? Well, the answer is you break them up. So this is the same thing as the summation as I goes from 1 to n of I squared, plus the summation as I goes from 1 to n of I, plus the summation as I goes from 1 to n of 1. And we can do that, and then, well, we just plug in our formulas. So I squared the summation of I squared was n plus 1, 2n plus 1 over 6. I'm going to get this out of here, actually. Just move it over. Okay. The summation of I is n plus 1 over 2. And then we know this is like the summation of a constant. The summation of c, as I goes from 1 to n, is just n times c. So n times 1 is just n. And technically, we have the answer right here. There it is. There's our formula. We're just going to simplify it. Do whatever we can to combine this. But that's it. Now it's just algebra. So, all right. I was just about to ask if there's any questions. If you have any questions, send me a text. All right. So I'm going to factor out the greatest common factor. When you're actually doing these, a lot of times it's going to be easiest if you factor out the greatest common factor first. So in the numerator, the greatest common factor, everything has a 1. And the denominators, you actually do backwards. Instead of the greatest common factor, take the least common multiple. So the least common multiple of 6 and 2 is 6. The idea is, by factoring this out, I don't want any more fractions left. That's why I take the least common multiple of the denominators instead of the greatest common factor. So if I take n over 6 out of this first term, well, the n and the 6 are gone. So I have n plus 1, 2n plus 1. For this guy right here, let's think about this. I mean, obviously, if the n is gone, then I'm just going to have n plus 1 in the numerator. But I'm taking out a 1/6 from 1/2. I'm going to have 3 left. I mean, the easiest thing is just do 6 divided by 2 to get 3. But if you think about this, if you're to multiply it back in, the 3 would be on top of the 6. 3 over 6 is 1 over 2. So that's why it works. And then if I take it out of here, I'm going to factor out the n, but I still have 6 left. I'm taking 1/6 out of 1 to get 6. How many sixths are in 1? There's 6 of them. But again, 6 over 6 is 1, so that would work. So you can see no more fractions. And then we just work with what's inside. So I'm going to multiply these two together. I'm going to have to FOIL them out, distribute the 3, combine like terms, see if we can factor. We'll see. All right, so we'll multiply these two together. N times 2n is 2n squared. Then we're going to have 1 times n is n, and 1 times 2n is 2n. So n plus 2n is 3n. And then 1 plus 1 is 1. Distribute the 3. All right, let's combine like terms. We have 2n squared, and then 3n plus 3n is 6n. 1 plus 3 plus 6 is 10. We can factor out a 2 from that. And when I factor out the 2 from here, it's going to cancel out with the 6 and make it a 3. So I'm going to have n over 3 left and have n squared plus 3n plus 5. And that quadratic does not factor anymore, so I'm going to leave my answer like that. And voila, we have a formula for the nth partial sum. So that's the first example, and that's pretty much what we do for all of these. Okay, for the last 2 examples, I'm just going to use this set of directions for both of the examples. And this is exactly like the directions for the first chunk of your homework tonight, so it's going to help you hopefully understand what you're supposed to do for all 3 parts. It's actually not that bad, the first 2, and then part C is basically doing what we did before. So I'm going to give you a series written out. You'll have to find the formula for a sub n. I'm not going to give it to you this time. Write it in a sigma notation, which is what we did above, and then use the formulas. So let's see how this goes. Here's our first example. well, I guess it's really our second example, but our first example using these directions. So what if I gave you 1 times 3 times 5 plus 2 times 4 times 6 plus 3 times 5 plus times 7, whoops, plus, and we have to find a formula for a sub n? Well, if you want to pause the video and think about this, totally go ahead. And I mean, this is tricky, but you do have the skills to be able to do this. So yeah, go ahead and pause the video. I definitely encourage it. Okay, let's take a look at it together. One instinct you may have had is, well, let's multiply these together. So we get 15, and then 8 times 6 is 48. Ooh, and then 15 times 7, 35 times 3, was it 105? I don't know, I might have that wrong. The point is, though, it doesn't matter. This is not the way you want to do it. You may have noticed, just not knowing what to do with it, that there definitely is a pattern in the numbers. Like, I'll bet that a lot of you guys could have given me the next thing, the next triple of numbers that you would add for the next term, and kept going like that. If you didn't see it, look at it factor by factor. Look at just the first factors. The first factors have a nice pattern to them. They are just 1, 2, 3, and it would go 4, 5, 6, 7. So what is that? Well, whoops, let me change back to green here. It's an arithmetic sequence. It's just going to be n. 1, 2, 3. First term is 1, second term is 2, third term is 3, the nth term is n. So that's from our first one. Okay, let's go ahead and take a look at the second factors then. Focus on 3, 4, and 5. So for the second factors, can we come up with a formula for them? And again, we can, because we can just go ahead and it's just arithmetic. We're increasing by 1 each time. So d is 1, so it's going to be 1n plus 2. What would come right before 3? It would be 2. All right, that was easy. So then 5, 6, 7. Oh, look at that. That has a nice pattern also. So our third factors, that's a sub n equals n plus 3. Nope. N plus 4. Again, we're just going up by 1 each time. 5, 6, 7. So d is 1. The slope is 1. But what comes right before 5? It's going to be 4. Then if you put all those together, for our sequence, then a sub n is equal to n, n plus 2, n plus 4. And that's the answer to part A, finding a formula for the nth term. So it's not that bad if you take a look at it. So just break it up, and break it up into like 3 separate problems. Okay, so then, now that we got that, now we have to be a little careful rewriting in summation form. And the only reason I say a little careful is, notice we don't know where we're stopping. We're going towards infinity for part B. Part C says, okay, stop at the nth term, but part B just says rewrite in summation form. So right now we're not stopping. So just be careful. Part B is going to be the summation as, and you can use whatever variable you want actually, because we're not, like I said, we're not stopping at n. If you want to keep it n and just say this, it's totally fine, because n isn't being used elsewhere in part B. So then we have that. But now part C. And so for part C, now we are doing the nth partial sum. So we're going to go from the summation as I goes from 1 to n, because this time we do have to put n as the upper limit. and it's I times I plus 2 times I plus 4. And then you're just going to want to multiply all this out and put it as a polynomial in standard form and use those formulas we had above. So again, I'm going to encourage you, pause the video, try this on your own, and then come back and take a look. Otherwise, we're going to work it out together here. Let's just scroll it up here. Yeah, if I can get it to stop. There we go. Okay, so we have the summation as I goes from 1 to n. So like I said, you have to multiply all this out. And when you do, you're going to get I cubed plus 6i squared plus 8i. So now we have that. Break it up. Now the one thing here, it didn't come up in example 1, but we do have coefficients. We have a 6 and an 8. Factor out the coefficient from the summation. So it's going to look like the summation of I cubed, as I goes from 1 to n, plus 6 times the summation of I squared, as I goes from 1 to n, plus 8 times the summation of I, as I goes from 1 to n. So notice the 6 just comes out and the 8 comes out. You would have a 6 in every single one of these terms, so I factored it out. And then same here, when you expand it, you would have an 8 in every one of those terms. So that's why we can do that. But now you can see it's set up for me to just plug in my formulas. And so I'm going to plug in the formulas that I gave you at the beginning, and then it's just a bunch of algebra at that point. So the first one, going back to the formulas, n squared times n plus 1 squared over 4. And then we have the 6 as our coefficient, so I'm just going to put that in the numerator. But then it's n plus 1, 2n plus 1 over 6. And then I have the 8 that I factored out, but then the summation of I is n plus 1 over 2. Okay. Now, some of you guys may have thought, well, why did I write 6 over 6? Just cancel them out. Personally, I know I will confuse myself if I do that too early, so I just write it out here. And then, you're right, I'm going to cross out the 6, and then 2 goes into 8 4 times. I wait until this point. It's just so I can keep track of things, because I'm not that good. All right, so now we're going to factor out. It's going to be much easier if you factor out now, rather than trying to multiply all this stuff out and putting it in standard form. Factor out first. So every single term has an n, and an n plus 1 in the numerator. So I'm going to factor that out. And then in the denominator, remember, instead of the greatest common factor, it's the least common multiple, which is 4. So if I take this from the first fraction, I just have n plus 1 left. If I take this from the second fraction, I have a 4 times 2n plus 1. And then if I take this from the next one, let's see, I'm going to have 16. Oh, and that's it. And again, just always double check if you're unsure about the fraction part. When I multiply this by the first fraction, I'm just going to have it over 4, which is what I want. The second one, when I multiply this fraction times the second term, I'm going to have 4 over 4, which is 1 over 1, which is good. That's what I want. The next one, I'm going to have 16 over 4, which is 4 in the numerator, which is what I want. So there's that. See, now this is much easier to multiply out and put in standard form. And so that's what I'm going to do. Like I said, it's just algebra now. So it's n squared plus n plus 8n plus 4 plus 16. Combine like terms. We have n squared plus 9n plus 20 all over 4, and that actually factors to n plus 4, n plus 5. And so there's my formula for S sub n. So let's look at what we did real quick, because it is really quick. We looked at each term factor by factor. So when it's multiplied out like this, or when it's factored out like this, I should say, you can just look at each factor and see a pattern and then put all that together for your formula for a sub n, which gives you your sigma. You're going to have to multiply all that out to get it in a polynomial in standard form, but then you can split it up into these different sigmas and use the formulas that I gave you, these formulas here, and then it's just a bunch of algebra to try to write it as factored as you can, and voila. Okay, so we're going to do, like I said, one more example, and then we'll be done. Let's see, I need a new page. And this is using those same set of directions. So this one's going to be 18 plus 32 plus 50 plus 72 plus doot. All right. Well, I'll tell you, for your homework tonight, you do have arithmetic and geometric hidden in there. So if it's arithmetic or geometric, be on the lookout for those, because then we have nice simple formulas to use. This is not arithmetic or geometric. So what do we do? Well, one thing you can do, I mean, next time we're going to learn another technique that you can do when you're given something like this. But for now, we don't know that technique. It wasn't factored out like that previous example, but I wonder if we did factor out, if we'd be able to find something with a pattern. Now the only problem is there's so many different ways to factor out the 18 and the 32 and the 50 and the 72. So which way do we factor it out? And this is where, for now, just kind of trial and error. Like, let's say that I tried 2 times 9, 32. What's 32? Well, 4 times 8. That's 5 times 10, I know. That's 8 times 9. Let's see, do we have any kind of pattern? 2, 4, 5, 8. Just looking at the first, well, that doesn't look good, does it? Second factor is 9, 8, 10, 9. Ooh, yeah, that's definitely not a pattern. Let's see, but I know 18. Let's see if instead of that we just did 3 times 6. 3, 4, 5. Oh, wait, that's an 8 though. Oh, but wait, 3, 4, 5, 6 should come next. And 6 goes into 72. Let's see, that would be 12. Would that work? So we got 3, 4, 5, 6. The second factors are 6, 8, 10, 12. Oh, look at that. It does work. Let's use this. So, like I said, just kind of trial and error until you figure out what works. You're not always going to be able to do that. But for tonight's homework, if that comes up, you will be able to do that because we don't know anything else right now. So, well, we got that. Let's see what we can do with it. And I'm going to do the same kind of thing we did before. So looking at just the first factors, they're just increasing by 1. So we have 1n plus 2 for that. And then for the second factors, well, this time they're increasing by 2. And then what would come right before 6? It would be 4. So there's my things there. So for the overall thing, it's going to be n plus 2 times 2n plus 4. Dun, dun, dun. And there we go. There's the first part. That's part A. Part B then, very simple. You just copy that same exact formula for a sub n into your argument. Boom. No work for part B. If you got part A, you got part B. And then part C, we're just going to multiply it out and use the formulas. So the nth partial sum is the summation as I goes from 1 to n of I plus 2 times 2i plus 4. So that's going to be the summation of 2i squared plus 8i plus 8. Double check. I times 2i is 2i squared. I times 4 is 4i. 2 times 2i is 4i. You get 8. And 2 times 4 is 8. Yeah, that's good. All right, then I'm going to factor it all out, split it up. 2 times the summation of I squared, as I goes from 1 to n, plus 8 times the summation of I, as I goes from 1 to n. Be careful on the last one of trying to do this, trying to take this 8 and put it out in front, because what are you going to put in here? You got nothing left. You can't do that. So you're going to have to leave the 8 inside here. That's the constant one. So, all right, then you just go ahead and put the formulas in. So this 2 I just brought down, but then the formula for I squared is n plus 1, 2n plus 1 over 6. I brought the 8 down, but then the formula for the summation of I is n plus 1 over 2. The summation of a constant, 8n. There we go. Now I see if I can simplify, and the can. Unfortunately, the only thing that factors out from the top is an n. Nothing else. Bummer. So I can factor out an n there. My least common multiple from the bottom is a 3. So I'm going to have n plus 1, 2n plus 1 from the first fraction. And then I'm going to have a 12, n plus 1. And then I'm going to have 24. And again, 12 over 3 would give me the 4 that I want. 24 over 3 would give me the 8 that I want. So I have all of that. Multiply it out, combine like terms, see if it factors, and then we're done. So we're going to have 2n squared plus 3n plus 1 plus 12n plus 12 plus 24. I'm going to have 2n squared plus 15n plus 37. I don't think that factors. We're done. Ta-da! So that's the kind of stuff. Now, like I said, for tonight's homework, you're going to have a little bit of arithmetic and geometric in there too, so be careful. The last couple of problems, I think it's the last 3 or 4, there's some deeper thinking problems, but the first chunk of problems are going to be problems like these. You only have like 11 or 12 problems for homework. I forget how many exactly. So it's relatively short. I know these problems take a little bit longer to do, but it's relatively short. It's not too bad. And then that's it for the videos. So have fun with the homework, and I'll see you in class. Bye.